Assalamu alaikum wa rahmatullahi wa barakatuh. Now we are going to talk about system modeling in chapter 5. On lecture 1 we are going to cover context and interaction models. First of all, what's really model? A system model represents an aspect of the system and its environment. There are many different types of model, as there are a variety of purposes for which they are built. It is useful to have a common way to talk about the concept underlying the many different types of models. So in this chapter we are going to cover the system modeling from many different viewpoints. We are covering in this lecture two viewpoints or two different perspectives: the context model and interaction models. Well, what we are going to cover in the whole chapter, we are going to cover the context model, interaction model, structural model, and behavioral model. And at the end, we are going to talk about the model-driven engineering. So in this lecture, we are going to cover the first two perspectives, which it is the context model and the interaction model. As we did explain and define what's really system modeling, we do it in different way now. System modeling is the process of developing abstract model of a system, with each model presenting a different view or perspective of that system. This means from where we look at the system, the way we look at it as external or behavioral or the structure of it. System modeling has now come to mean representing a system using some kind of a graphical notation. So in the model, of course, we're gonna create a model using a graphical notation, which is almost always based on notation of UML, Unified Modeling Language. System modeling helps the analyst to understand the functionality of the system, and models are used to communicate with the customer. So we have to understand what's the functionality of the system. When we understood that, we could easily build that model to fulfill our knowledge about the system. So these models are used to communicate with the customer. So the first thing really, when we use the model, since it is an abstract view, I think it is good to deal with the model as a communication tool to the customer, to explain to him what really that system and how it's gonna do it in many different perspectives. As we saying in every time, we know when we wanna start collecting requirement, when we try to build a model, anytime we have a project, we have to look at the existing system, the document of the existing system. In the case of the requirement, we look at the form, the procedure, the type of requirement the system is doing, the pieces of it, process it, whatever. In case of modeling, we gonna look at the document again to figure out what are those models. So the model of the existing system are used during requirement engineering. What for? To help clarify what the existing system does, to find out what's the problem, in order to find where is the strength and the weakness, in order to find the problem of the existing system. So in order to fill the problem definition, we have to find out what is the system and how the system is doing the function now, in order to try to fix it, to come up with the model of the new system. The model of the new system are used during requirement engineering to help explain the proposed requirement to other system stakeholders. Engineers use this model to discuss design proposal and to document the system for implementation. Of course, after we take the existing system, we made the change to it, adding a new step, get rid of process, combine two processes, whatever, we're gonna come with the new system models. And that one we could communicate and explain to the customer how the new system will fulfill their requirement. The last thing, or the last model, it is a models-driven engineering process, which is possible to generate a complete and or partial system implementation from the system model, and the one we're going to discuss it later in the chapter, probably in lecture 2. If we look at the viewpoints, perspective, the way we look at the system, from what angle we look at the system, so we could come up with many different system models, like categories for the system models. The first one, we're going to look at it as from external viewpoint. We look at it and we come in external perspective, where you model the context or environment of the system. And in this case, we are going to cover the context diagram. The other perspective, or the other view, we look at the system, how really these pieces of the system interact with each other, where you model the interaction between system and its environment, or between the component of a system. The component of it, the system, how they interact with each other, and we represent that one in use case and in class diagrams, in sequence diagrams. Structure perspective, where you model the organization of a system, or the structure of the data that is processed by the system, and we are going to cover as an example the class diagram in this, and it will be in lecture 2. Again, for the same for the behavior perspective, where we model the dynamic behavior of the system and how it responds to an event, like if then else. We have a stimuli and response. We have an event and response to it. Behavioral diagram, we call it a state transition diagram, and again that one will cover it in lecture 2, hopefully at the end of this chapter. As we said, we are coming with a lot of diagrams, and all these diagrams, they are gonna fall under those 4 perspectives, the one we covered in the previous slide. Like activity diagram, which show the activity involved in a process or in a data processing. And this is, of course, it is interactive diagram. A use case diagram, again, which show the interaction between a system and its environment. It is interactive. Sequence diagram, which show interaction between actors in the system. Again, this one comes under the interactive perspective of that model. Class diagram, which show the objects classes in system and association between these classes. This is static one, so it comes under the structure perspective. And finally, the state diagram, which show how the system react to internal and external. It comes under the behavioral model, which it is the behavioral perspective of the models. Well, why we are using the model? There are many different reasons for using the model, graphical models, whatever. The first purpose is, as a mean of facilitating discussion. I mean, when we start really building a graphical model, whatever, and we're gonna discuss it with the customer, probably that model, it doesn't have to be complete or correct. So why? Because we are discussing this one. So it is really, we could apply some changes to it and addition to it. So it doesn't have to be complete or correct. The other reason or purpose of it as a way of documenting existing system. If we have an existing system, probably that system, it's not complete, but it has to be accurate. So we take that system and we document it. The model, it has to be correct, but it doesn't have to be complete. But the third purpose, it's as a detailed system description that can be used to generate a system implementation. It is a complete, it is a full system, it has to be correct, and it has to be complete in order to build it and make it, fulfill all the requirement in case of the implementation. Model in this case has to be both correct and complete. Well, context model, which it is the one really we use, is the context diagram. Context diagram, which is sometimes called a level 0 data flow diagram, and that one we cover it in the system analysis and design, is drawn in order to define and clarify the boundaries, the scope of that system. It identifies the flows of information between the system and its entity. And actually the entities are external entities. It's like the stakeholder around them. Usually the context diagram, we have it in either with a circle or a square and the external entities around it. And the data flow or the arrow, it goes between the diagram, this boundary, and it is external entity. It's like, the user who are gonna interact with that system. In this case, we talk about it as we're saying context models are used to illustrate the operational context of a system. They show what lies outside the system boundaries. Social and organization concern may affect the decision on where to position system boundaries. Architecture models show the system and its relation with the other system. Architecture model or the context diagram, it shows, the boundary of the system and the environment. It could be there are many different constraints on that boundary, what's really in the system. And usually in the context diagram, we should show what's in and what's not in the system. Well, as I mentioned just a few seconds ago, system boundaries are established to define what is inside and what is outside the system. Because we need to define accurately what is in the system, what the system should contain, in order to find out if it is doable or not. So we do the feasibility study. Then after that, what kind of risk probably we could face, how much money, the schedule of the system, how long it takes. They show other systems that are used to depend on the system being developed. The position of the system boundary has profound effect in the system requirement. Of course, that system, that boundary is the one, it will lead us to the type of requirement and the kind of requirement and the number of requirement for that system. Defining a system boundary is a political judgment. Well, not really political, but it depends on the money they have, what really include in this boundary, what's not include. It depends on the situation of that company. Well, the context of the mental health care patient management system, the author here, they follow, different path to the context diagram. He did it in different way. Actually here, the system, mental health care patient management system, the one, that box in the middle, and the other 6 boxes around it, those are the contents of the system. Those are part of the system. Actually, the way we explain it and the way it should be, when we talk about the context diagram, we put, a square around the whole thing. Or actually, we could really put just the system mental health care project management, patient management system, and then around it, the stakeholder, the people who are going to deal with the system, like the patient, like the doctor, like the nurse, whatever. That is, in the definition we just did a few slides ago, we mentioned about level 0. Level 0 is the major entity of that system. And actually, in this case, the context diagram, it is just one process, which is the name of it. When we go and explode it, when we decompose the system, we compose it to the other 6 parts here, like the management reporting system, the statistics system, the appointment system, the prescription system, and others, and the patient record system and other systems. So if you look at the context diagram model, or from process perspective, It will simply show the other system in the environment, not how the system being developed is used in that environment. But the process model, which it is reveal how the system being developed is used in a broader business processes. UML activity diagram may be used to define business process activities, and that one, it is actually in the interactive perspective of that models. Well, if we go through this slide, we'll find the process model for involuntary detention when they want to detain one of those mentally ill patient. So this one, it goes, between like two systems. One of them, the mental health care PMS, those and the one at the bottom. It comes, the first part of that process. And then the last part, the latter part, it go to the mental health care. In the middle part, it go to the administration system. There is an admission system, actually, not administration, it's an admission system. First of all, they have to conform the detention decision. They have to really decide that, hey, they are going to detain this patient. So first thing they're going to do to inform the patient of its right. It's exactly like, لما الشرطة بيعتقلوا واحد بيعطوه الحقوق تاعته, الرايت تاعته. Then they record the decision, detention decision, and these two processes, whatever, they are a part of the mental health care patient management system. Then it goes to the admission system, where we're going to admit that patient. Are we going to admit it like in a hospital, whatever? So they have to decide, find a secure for him, and see if really he is dangerous or not dangerous. I mean, if it is a dangerous person, they have to find a secure place for it. So you could transfer it to either a police station, or you send it to a hospital with a secured environment there. But if it is not dangerous, you just, admit to the hospital. And then after that, you go back to the mental health care patient management system to inform the social care agency. Then you inform the next kin, which it is, his family or her family or whatever. And then you update the register. We update the information about that patient, in the mental health care patient management system. Well, we go to the second perspective, which it is the interaction perspective or interaction models. Interaction models is a model that binds all application of the system together in a way that support the conceptual model of the system or of its target user, not of the system but of its target user. مفهوم الuser. It binds them together. It defines how all of the object and action that are part of the application interrelate, how they interact together. Modeling user interaction is important as it helps to identify user requirement. Modeling system-to-system interaction highlight the communication problem that may arise. So the interaction, it could come, system-to-system, component-to-component, between two components or between system-to-system. Modeling user interaction is important. As we said, it helps identify the user requirement. Modeling system-to-system interaction highlights the communication problem that may arise. Modeling component interaction help us understand if a proposed system structure is likely to deliver the required system performance and dependability. Of course, a use case diagram and sequence diagram may be used for the interaction modeling. And that's the one really we are going to cover in the following slides. Well, use case modeling. What is really a use case model? Use case model is a model of how different types of user interacts with the system to solve a problem. As such, it describes the goal of the user, the interactions between the users and the system, and the required behavior of the system to satisfy these goals. User or use cases were developed originally to support requirement elicitation and now incorporated into the UML. Actually, when the use case developed, it was really a scenario-based technique, the definition of it, which it is really used for requirement elicitation. Now, each use case represents a discrete task that involve external interaction with a system. Actors in a use case may be people or other system, as we are going to see in the next slide, represented diagrammatically to provide an overview of the use case and in more detailed textual form. Okay, the purpose of the use case diagram is to demonstrate the different ways that a user might interact with a system, as we just said in the previous slide. Create a professional diagram for nearly any use case using the UML diagram tools. Use case diagram can summarize the detail of your system user, which it is, we call them actors, as we are going to see shortly, and their interaction with the system. To build one, you will use a set of specialized symbols and connectors. So we'll find, the symbols and the notation and that one. An effective use case diagram can help you discuss and represent scenario, goals, and the scope of your system. When we look at this example, online shopping system, we have really three notations here actually. We have, the stick person, that one, which is the stick figure, you call it. We have the oval, which it is represent the use case itself. And we have the arrow. Not arrow actually, it is an arc. It's a line from the actor to the oval. The use case, it's horizontally shaped oval that represent the different uses that a user might have. In this case, you look at that one, there is a view, there is a make a purchase, there is a login. Those are the uses of a customer. Like the customer use that one, use that one, use that one. The stick figure or the stick person is really the actor who act with. And that one, it could be a person or it could be a subsystem. Subsystem deal with that use case or one. The arc is really the association, we call it. It's a line between actors and use case. Well, there is an extend. The extend in use case, actually, it is directed relationship that specify how and when the behavior defined is usually supplementary or optional. Extending use case can be inserted into the behavior defined in the extend use case. Extend use case is meaningful on its own. It is independent of the extending use case. What's that mean? Extend is used when a use case adds steps to another first-class use case. Let's look at this example. For example, imagine withdraw cash. When you go to the ATM and withdraw cash, it will be used, if is used a case of ATM, which is automated teller machine. Assess fees. If the ATM is in your bank, they won't charge you for any fees. But if the ATM you withdraw money, it's not your bank, then they will go to the assess fees as an extended use case. Assess fees would extend withdraw cash fee. The conditional extension point that it is instantiated when the ATM user does not bank at the ATM owning institution. Notice that the basic withdraw cash use case stands on its own without an extension. In other words, if you go to your bank and use the ATM, they won't charge you for a fee. Charging the fee, it is another program or a function there. It depends on you if you are belong to that bank or not. If you don't belong to that bank, then they extend the program to go call and find out the fees or charge you for extra fees for that. Oh, look, okay, for the include in the use case diagram, the include relationship adds additional functionality not specified in the base use case. It is used to include a common behavior from an included use case into a base use case in order to support the reuse of the common behavior. What's that mean? Include is used to extract use case fragments that are duplicated in multiple use cases. The included use case cannot stand alone, and the original use case is not complete without the include one. This should be used sparingly and only in cases where the duplication is significant and exists by design, rather than by coincidence. For example, the flow of event that occurs in the beginning of every ATM use case when the user puts their ATM card, enter their PIN, and is shown the main menu would be a good candidate for an include. Well, we have an example here for transfer data use case in a mental health care patient management system. You see that transfer data is the logic, is the use case, and the stick person or the stick figure medical receptionist interact with the transfer data, and then it goes to the patient record system. Notice the stick figure, the one on the right, it is a system. It is another system and represented as a stick figure, or it could be as a square or rectangle or whatever. But here it's a patient record system. It is like a stick figure. Well, in the case use case in the previous slide, mental health care patient management system transfer data, if you look at the actors represented by two people, medical receptionist and the patient record system. The description of that use case: a receptionist may transfer data from mental health care patient management system to a general patient record database that is maintained by a health authority. The information transferred may either be updated person information, address, phone, etc., or summary of the patient diagnostic and treatment. So, the update, it could be, the information about the address, phone, or whatever, or diagnosis and treatment of that patient. Data, of course, patient personal information or treatment summary. Stimulus, which it is, what's the event? The event used command issue by medical receptionist, which it is the secretary or receptionist. It can just go and issue a command. This is the event. But what's the response? The response is confirmation that the patient record system has been updated. If there is any comment, you could just put the receptionist must have appropriate security permission to access the patient information and the patient record system. So this is actually explanation of what really, or description in a table with we call it here tabular description of the transfer data use case. That's, it's clear. All the symbols of that data, of that use case is here clear. The action, the description, everything is all the elements for that use case. It is really described in this tabular description. Well, if we look at the example use cases in the mental health care patient management system, which it is involved the role of the medical receptionist. So we take a role of, one person who work on that system, and we see what really that person, is doing. In this case, for the medical receptionist, he or she will register a patient, unregister a patient, view a patient info, transfer data, and contact patient. And actually, the use case, the medical receptionist and the transfer data is the one we just see in the slide before, and the one we explained it just in the slide before, and the one even before it. Well, the sequence diagram shows the object interaction arranged in time sequence. It will show the object and the classes involved in the scenario and the sequence of messages exchanged between the object needed to carry out the functionality of that scenario. What does that mean? Sequence diagrams are part of UML and are used to model the interaction between the actors and the object within a system. A sequence diagram shows the sequence of interaction that take place during a particular use case or use case instance. The object and actors involved are listed along the top, as we are going to see in the next few slides, with a dotted line drawn vertically from these. Interaction between objects are indicated by annotated arrow. So we'll see the arrows. It goes from object to another object, and we'll see some of them dotted, and we'll find out what all these are. Well, this is a sequence diagram for viewing patient information. If we look at the top part of it, it has the stick figure and the patient information, mental health care database, as those are represent a class or object in UML. The object symbol demonstrates how an object will behave in the context of the system. If we go to the bar underneath of these objects, the one it goes down, the yellow one, the blue one, they call it activation box. It is a bar there, a narrow bar, whatever, or narrow box, represent a time needed for an object to complete the task. If we go to the arrow going from the actor, the medical receptionist, to the patient info. If we go to that one, which it means it is a message symbol, represent a solid line. This symbol is used when a sender must wait for a response. You just go there and send a message, and you wait until a response comes, after you go to other object and return something back to you. Here it shows, when the authorization come and the alternative, either authorized or not authorized. If we look at the dotted message, which it's go from right to left, this is a return message symbol. So there they return the authorization, they return the patient information if it is unauthorized and it's okay, or it return an error, which it is no access if the authorization failed. These symbols are very, very important to know and understand what really each symbol of these, and in order to try to construct a sequence diagram. In this case here, the medical receptionist try to view the patient information. Of course, it goes to the to the database, and then when it go to the database, from that it sends something to the authorization. This means that is this guy who, receptionist, is really authorized to look at these record for the patient or not, which is something to do with the security. Down there, the big box, one which it says it has alternative there, Now it is if he or she authorize the patient information, it goes back. If it is not authorized, it comes with an error, no access. Well, again, another example for sequence diagram for transfer data. Again, the medical receptionist, the patient info database, and the authorization, and there is a fourth object here, or a fifth object, which it is the patient record system. We need to transfer a data, to that record. So you log in to the patient register system, record system, and then if everything is okay, then it comes back with a dotted line, and there are some alternative. It depends on that one. You could really upload and load these things, or if you are not allowed, it give you an error. So it is the same thing. The only thing really we need to find out what those symbols are, what is really the stick person, what is those object at the top, what is the bar or the rectangle, the one small rectangle, the one in the yellow, what means, which is the activity of that object, and then what's the dotted line goes back, and what is the solid arrow, it goes, it has a message, and the message come back, return message, and that one it has some parameter or a message go to that object. So by this sequence diagram, whatever we end this lecture, and next lecture will cover the rest of these models. Bye.